Hello everyone, my name is Yazeed Alharbi and I work with Professor Peter Wonka at KAUST on disentangled image generation through structured noise injection. The main goal of our method is to enable editing randomly generated images. Networks already perform the more difficult task of generating realistic images, but they fail to perform the simpler task of editing. In order to achieve the main goal, we aim to restrict the influence of certain noise code entries to specific regions in the generated images. Furthermore, we aim to separate global and stylistic details from local details. Our method is guided by two observations. First, there are multiple ways of using input noise codes. The traditional way is to directly map the noise code to a tensor. An example of this is DCGAN. A more recent way is to use the noise code to compute instance normalization parameters for each channel in the network. Examples of this are style-based generators. The second observation is the strong spatial correspondence between the input tensor and the final image, such that changing the top right entry in the input tensor merely affects the top right region in the final image. Guided by these observations, we propose an architecture that achieves a high degree of disentanglement. Our network accepts two input noise codes. The spatially variable codes allow resampling specific regions of generated images. The spatially invariable code defines most style and color information. We achieve spatial disentanglement by structuring the spatially variable part. It contains local codes, shared codes, and a global code. Each cell of the spatially variable code contains a unique local code, a code that is shared with neighbors, and a code that is shared for all locations. The global and shared codes are needed to encode information that spans multiple locations, such as pose and accessories. Moreover, each cell has a separate, fully connected layer that is independent from other locations. This guarantees the independence of the local codes after mapping. The other input noise is the spatially invariable code. We leverage its suitability for expressing stylistic information to complement the spatially variable code. Without using a spatially invariable code, we found that local codes can change background and style in addition to changing local details. Our method leads to significantly better disentanglement scores when compared with the state-of-the-art method, StyleGAN. Path length measures the influence of interpolating two sets of codes on the resulting interpolated images. Higher path length indicates an entangled mapping, where small changes in the codes lead to large changes in the images. Linear separability measures how inaccurate linear attributes classifiers would be when trained given only the input codes. Higher linear separability scores indicate an entangled mapping, where attributes are not linearly predictable given the codes. Our method enables disentangled editing of many image attributes. After generating a random image, we demonstrate the effect and quality of resampling parts of our codes. Resampling the global part of the spatially variable code affects pose. Although some other details are also changed, the likeness of the person and the background style remain the same. Resampling the shared part of the spatially variable code affects face dimensions and accessories. It can be used to change age and add glasses. Resampling local codes that are centered around the mouth changes the shape of the mouth. Resampling local codes that are in the top rows changes the hairstyle. Resampling the spatially invariable code shows a desirable effect. Pose, age, and facial expressions are kept. We observe that the shape of the clothing is also kept. However, the background, ethnicity, and sex are changed. Finally, our work can be expanded in the future to tackle other research problems. The first research problem is the possibility of completely separating content and style in the generation process. This would enable changing the background while preserving the same face image identity. Another problem is whether more control can be offered in the spatially invariable code. For example, whether it is possible to change ethnicity while maintaining all other stylistic aspects of the face image. Additionally, more research can be done to determine what kind of decomposition of the generation process is more suitable.